Hello everyone, welcome to my math class. Today we are going to look at how to simplify square roots of natural numbers. We will start with perfect squares. It is very helpful if you're familiar with these common perfect squares, 1 squared to 20 squared. I will suggest you to remember all these perfect squares. And let's move on to properties of square roots. For positive numbers a and b, if we have the square root of a times b, then it is equivalent to the square root of a times the square root of b. And here a and b both are positive. Similarly, if we have the root a on b, then this one is equivalent to root a divided by root b. Same, a and b both are positive. For example, if we have root 10, then this one is equivalent to root 2 times 5, and then we can separate this one to 2 square roots with root 2 times root 5. And also if we have root 2 on 5, then this one is equivalent to root 2 over root 5. So it is quite important to remember these properties of square numbers. Then let's look at the definition of the simplest form. So when a number under the square root has no factors which are squares of a rational number, then the surd is said to be in simplest form. For example, if we have root 7 and then 7 is not a square of a rational number, then it is simplified form already. And then if we have root 16, then we know 16 is the square of 4. Therefore, this root is not the simplest form. It can be simplified to number 4. Let's look at root 50. And then here we do not see the perfect square of a rational number directly, but we can try to factorize 50. So we can use the factor tree. For example, 2 is a factor of 50, and then 50 can be factorized 2 times 25. And once we see 25, we know 25 is the perfect square of 5. Then we are going to use the property. It can be separated to root 2 times root 25, and then root 2 times 5. And normally we put the whole number to the front. Then the simplest form is 5 times root 2. Now let's look at this example. For part A, we have root 72. Then similarly, 72 can be factorized to 36 times 2, and use the property it can be separated to root 36 times root 2, and 36 is 6 squared, therefore root 36 will be simplified to 6. Then the simplest form of root 72 is 6 root 2. Then for part B, root 28. Now let's look at part C. We have root 700 on 117. So for this one, we can separate the numerator and denominator. So we have root 700 over root 117. Then for the numerator, root 700, it can be factorized to 100 times 7, and 100 is 10 squared, therefore it can be separated to root 100 times root 7, and root 100 is 10, and 10 root 7. Then for the denominator, we have 117. So if we can't factorize it directly, then we can use the factor tree, because 1 plus 1 plus 7 is 9, therefore 3 is a factor. So when it's divided by 3, we have 39. And 39 can be factorized to 3 times 13. Therefore, we are going to have 3 together, then it means it can factorize to 9 times 13. And then separate them, we have root 9 times root 13. Then root 9 is 3, and then root 13, we are going to keep it. And now the denominator has the square root, then we can multiply root 13 for both numerator and denominator. Then the result will be 10 root 9 over 39. Finally, let's look at part D.